All right, we're going to look at linear relations, linear equations. People call them functions too, but I'm not technically going to call them functions because of the way that we're going to deal with them. They're more of equations. So linear equations, we have a couple different formats that we're going to use. We have slope-intercept form, which you guys have been dealing with for a long time. That's y equals mx plus b, where m is your slope and b is your y-intercept. Then we have point slope form. Point slope form is in the form y minus, I'm going to put little y. Most people put y1. I don't like that. This y stays a y always. Equals mx minus, and I'm going to put little x. And sorry, this one stays an x always. So for this one, these two are a point, and m is still your slope. Then we're going to have standard form, which some people call it general form. I call it standard form. It's just the way it goes. That's where we say ax plus by equals c, where these are all integers. They're the least common multiple, lowest common value, meaning like if I had 4, 8, and 12, it would actually simplify to 1, 2, and 3. And then this isn't technically a rule, but somebody decided it was at one point, and we pretend that it is. This has to be positive. All the other ones don't matter. So we're looking at that. We're also going to look at how to find the slope. We're going to look at how to find the slope, which I'm just going to change in y over change in x. This means this is a delta. It's a Greek symbol. It means the change in, so, or the difference of. So a lot of times you'll see y2 minus y1 over x2 minus x1. You guys are pre-AP, pre-cal. You really shouldn't be talking in those terms. You should be talking in these terms. So let's say they give me 2 points, and it asks me to write it in all 3 different ways. The first thing I'm going to do is I'm going to find the slope. So I'm going to go 7 minus 3 is 4 over 4 minus 2 is 2. So I have a slope of 2. So in point slope form, I would write it as y minus 3 equals the slope x minus 2. In slope-intercept form, I can distribute this, which is going to give me y minus 3 equals 2x minus 4. And then I can add the 3, so it's going to be y equals 2x minus 1. And then standard form, what I need to do is I need to distribute right here, and then bring the x over, and bring the 3 over. So I can do it from here as well. I can subtract the 2x, so I have negative 2x plus y equals negative 1, and then multiply everything by negative 1, so I get 2x minus y equals 1. So that's my standard form. The other things that I'm going to ask you guys for is I'm going to ask you to find the x-intercept, the y-intercept, and the slope. Slope I already found. The slope is 2. The y-intercept I found right here. The y-intercept is x is 0, y is negative 1. And then I'm gonna find the x-intercept, or the 0, by plugging in 0 for y. I'm gonna add 1. I'm gonna divide by 2. So I'm gonna have 1/2, 0. So this is my 0, this is my y-intercept, and that's what I'm doing. So I'm going to do some more examples, but this is pretty much everything that we're going to do. So some more examples. If it told me something like this, and same rules, it's already in slope-intercept form, so I don't have to do that. To get standard form, I bring that over. So negative 1/2 x plus y equals 3. This is a fraction, so I'm going to multiply everything by 2. Whoops. Just give me negative x plus 2y equals 6. Multiplied by negative, so it's x minus 2y equals negative 6. So that's my standard form. And to get it in point slope form, I actually need a point. So the easiest thing for me to do is just pick a number to plug in and figure out the other value. So I'm going to try a number that times 1/2 gives me an integer, which would be like, I could use 2. 2 times 1/2 is 1 plus 3 is 4. So that means it goes through this point with a slope of this. So for my point slope form, I can write it as y minus 4 equals the slope of 1/2 x minus 2. And I can pick any number to plug in because I'm just finding a point on the line. So that's what we're looking at.